Hello, it's Scott Manley here with parts 13 of Shenzhen I.O. We have the spoiler blocking headphones. Like many of the people in the office, I'm a huge fan of the something or other miniseries, Get the Throne. The heroics, the villainy, and sudden plot reversals have my wife, Xiaomei, and I waiting with bated breath for each new episode. Unfortunately, we missed last night's episode, no doubt due to your dieting and stamina. And this morning I overheard people in the office discussing the latest twist before I could say anything. Surely there's some way to prevent the being spoiled like this, perhaps with headphones that replace discussions of certain television shows with scrambled audio. You want to list... Okay. So, what we have, and I've looked at the manual already, there's a supplemental section where David has come up with a list of words that we want to block. And the words are pairs of numbers, so I'm just going to start right away with a ROM and put these in. Now, yeah, a lot of people are saying, how do you so fast on these things? I'm going to be clear that in some of these levels where there's supplemental data in the manual, I'm reading the data ahead of time, so I have a pretty good idea what's going to be required of this, which is why I'm going straight into putting the numbers into the system. Haven't seen the rest of the problem, so we'll still have to figure that out, but I'm sure that knowing this ahead of time is going to really help me. Okay, so let's actually take a look at this. Audio in, audio out. Where's audio in? There's override, and there's audio out. I'm guessing this device has to be the audio in and out, so let's actually just hook this up. This is an X bus, and so we'll just move X1 into ACC and then sleep, and we'll just verify this. Verification, advance. Yes, so those numbers are indeed correct. Similarly, let's hook up P0 and see that P0 is in fact the audio input. I mean, it's the only input left, so I'm guessing that's what it has to be. Yep, those numbers all look good. Okay, so what we're gonna need is we're gonna need this thing, and we're probably gonna need both cable connections. We're gonna need to... Oh, wait a second. Let's do this. Because I want to get the P1 signal out here, right? So we want to have an output. We want to have an input, and if we want this as an input, we're going to need to use one of these gizmos to convert the override signal into an X bus. Like that. And therefore, we have all our connectors here. Okay, so now, first thing we want to do is... So what's going to happen is we're going to get data on the X bus, and if it comes up as a number, we want to check this number and compare it against this, and then the rest of the time, what does it say? The signal from audio in should look for the keyboard, spoiler rate stuff. Basically, we want a value of 50 until the override button is pressed. Okay, so dat will be blocking status. So if dat is high, then we block the data. So first thing we do is we have an X bus, and we're going to have to move X0 into the accumulator, and then test equal to, or test greater than, test equal to -999, and then we'll jump to LP, not LP, what would we do? Send. Test accumulator. Right, so send will be the audio loop, and the audio loop will say if, well actually we'll have to check X1 first, so TEQ, or T greater than, X1 is greater than 0, then we're going to move dat 0 into dat, so we're going to reset this. Otherwise, we're going to test if dat is greater than 0. If it is greater than 0, we move 50 into P1. Otherwise, we move P0 into P1, and then we sleep. There, sleep 1. So that's our loop. Now here's the more complicated part. We also need a thing here. Now we need to somehow iterate through this loop. And this is where it could get complicated. So we're going to have to step each of these one at a time. So let's just do this. TEQ. You know, we could actually just cheat on this a little. Let's see if this works. Test if accumulator is equal to, and this is x2. If so, do something. Otherwise, we're then going to need a loop signal here. LP, TEQ, or TGT. X3 is greater than 11. Then jump to LP. Right, so if that, and now we need two instructions. So wait, this is not going to work. Actually, it could work. This could work, assuming the person that wrote the tests hasn't thought of what I'm about to do here. So, if this is equal, then we need to now compare TCP test TEQ x0 against the next value in x3. And if so, oh no, that's not going to work because we're going to need to reset this. Okay, forget about this. We're going to have to move the sound loop into an exterior thing. Let's just put it into this. So, yeah. Just wait a second. We'll do this, and we'll move your sound loop in here. We don't have a DAT register, so we're going to store it in the accumulator. ACC. There we go. So move the override. Move. This pin type mismatch. Oh yes, of course. Turn it around. Thank you. Connect in there, and then this now has to connect to the sub-processor, and this audio out no longer happens. It would be really nice if I could do this audio out cycle with logic, but I don't believe I can. And then we need something on the X bus as well, like that. Okay. So let's just imagine I've got... Ooh! Actually, I have thought of an optimization already, and I might as well run with it. Perhaps premature optimization is a dangerous thing, but it is here, it is presenting itself, and what I can do is combine these. Wait a second. Oh no, wait a second. Yeah, that's what I can do. Look at that. That's going to be beautiful. And this one, we'll just hook around here. So what I'm doing is I'm combining both of these inputs so I can test the input status with a single instruction, because I'm thinking ahead to these kind of things. Okay, well, that's fine. Test greater than x1. So we're testing actually x1 is greater than, and what we're going to do actually, now this is P0, so that's 111, so we're going to do a TCP, I'm not sure we need this loop anymore, TCP x0 with 1. If it's 0, then we do nothing. If it's less than, if it's less than, we do nothing. If it's 0, then we set the accumulator, right? Because that's the first bit, so we're going to move 1 into the accumulator, or 100 into the accumulator, I guess. Otherwise, we're going to move 0 into the accumulator, and then if the accumulator is greater than 0, we're going to do that. P1, sleep. That's our loop, right? So we've now combined all this here, so this thing just needs to go high at the appropriate moment. Now, let's jump. We're just going to jump to sleep now, because we don't need the sleep. We're going to need this sleep at the end, but always. And actually, I'm going to do this. I'm going to gen. This is something that somebody pointed out to me that I didn't realize, right? We're going to gen a 0 pulse here instead of sleeping. So if we need it, that's what's going to happen. Otherwise, we're going to set that low. So now we fall through and we're going to test our accumulator against x2. But before we do that, let's just move our x0 into the DAT register. So we now got both data things in memory, right? And we should move our address to 0. Let me just check here. Move x3. Oh yeah, move 0 into x3. So we're going to reset our loop. And our test of greater than, jump to LP, that's fine. So test if the accumulator is equal to x2, and then if it's not equal, then we don't do anything. We just gotta read something from here. So we'll move x2 to null. Doesn't really matter. Or we do a TEQ against DAT and x2, and if that's true, that means they're both equal. And we're like, spoiler! So I'll call that SPL, jump SPL or something. Otherwise we'll fall through. So how do we generate spoiler? We do this. We gen one, P0, 1, 0, and then we jump to the start. SD. There we go. I think this is gonna work. Wait, it's not giving me a simulate. What's missing here? Verification. Why isn't the verification gonna run? It's complaining. Oh, it's complaining about this. There, that's the thing. Simulate. Oh, and it's not working. Why is this not working? We're moving 50. Moving P0 test greater than. If accumulator is greater than 0, let's do this. Why is it greater than 0? Oh, because I need to... That's a really dumb idea. I totally got that wrong. If 0 is coming... Oh, you know... Oh, wait a second. Let me just think. What we want... I mean, what we can do here is just... force this to go to 0, right? Oh, no. I was thinking I could double test this here. So, if this... I thought I could do this in a single instruction. What am I missing? Move P0. P0 is either... If it comes in here, that's 1. And then we don't execute anything there. If it comes in here, then it's 10. And we do something. But if it's 0... then we want to just jump through. That seems wrong. I think I'm doing something wrong here. Let's just jump through to this. Jump to TST. That's what I'm doing wrong here. Let's do that. Okay, that's working. There's a bit of a glitch there. What's happening here? Advance. And this goes to 50. But we jump straight to test. So how does accumulator get set? Hold on. So our state is 100, and our state is still 100. And why are we not generating... Why are we we're generating 49 versus 49. So we're not catching this immediately. And the reason is... This is a synchronized X bus, so maybe my optimization was a boatload of bunk. Let's just take this optimization out. Let's just use a blocking X bus here. So we're going to do that, and then this is going to have to come in via the standard X bus route. So we'll do this over here, right? And that way I can't generate a pulse. So that's fine. Just move. Yeah, okay. That was a needless optimization anyway. Move 0 to x1, or move 0 to x1. I made really stupid mistakes. SLP1. And we're going to remove the sleep. The sleep is actually going to be... Okay, so that's actually null. And then this is going to be sleep. And then this is going to be jump to sleep, right? So, and this has to now jump to null. Okay, let's try this now. Simulate. And it gets nowhere. Part is not sleeping because we're not actually doing the comparison. Yes, because I've got to rewrite this whole thing. Ah, yes, people are just like face palming right now, but this is just what happens. So yeah, if x0 is greater than TGT x0, what order do we do things? If x0 is greater than 0, then move 100 into the accumulator. Otherwise, if TGT, if x0 is greater than 0, then move 0 into the accumulator, and we fall through and we do all this stuff, and everything should work this time. Simulate. Oh man, it's not working! Why is it not working? Test 0, test greater than 0, move 0 into the... Why is this not getting set? We're reading this value out. Advance, 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 advance. There's something wrong with my test loop here, right? I keep doing this. Advance, 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 advance. Step. So we're not equal to that. We're moving 0 into that. Moving into that. And then we're moving 0 into the X3 register, which should reset the pointer. And then we're testing. Nope. Otherwise, we're just skipping. We're jumping back. So we're doing 2 reads per cycle. Again, doing that. What is our number? 575. So we're doing the second thing. Oh, moving 0 into x1. We're moving 100 into x1. That's our problem. Simulate. Yes! Okay, now Get the Throne will remain spoiler-free for Xiaomei and David, and the world will be a happy place, and except for the people living in that world. I'm sure I can optimize this. I know I can optimize this using the same hashing technique that I used on the security lock, but we'll come back to that. Let's return to the email. You have made many fans of the popular shows like Get the Thrones happy to know they are not in danger of spoilers as they walk into the office in the morning. Certainly, when my wife Xiaomei and I are very much looking forward to last night's episode, knowing that we will be genuinely shocked by the events to come. You're gonna love it, man! I couldn't believe the Emperor was actually alive the whole time! Oh, Joe, you butt of many jokes. That is actually pretty hilarious. I'm also looking at some of the other shows in the supplemental, and it's like Truth Investigators and their keywords. Memories of Tomorrow, but my favourite is My Roommate is a Lamia. With spoilers such as Lamia, succubus, bass guitar, seatbelt, tissue paper, and dental insurance. Now, if anybody in the comments can write a TV show where those are essential spoilers, you're gonna get a shout out for being funny. Okay, so this optimization, instead of using memory, uses two external things that basically look up 3 possible locations, and we pick which one to go to based upon whether the first digit is a 500 or less than, greater than 500 or less than 500. There's also an extra sleep in here. It does mean that this whole block of logic has gone out here. And how does it weigh up? Well, the whole idea is that we're trying to go for the least amount of power here, because we're certainly not winning in terms of instructions. So we've now knocked our power usage down to 798, but yeah, lines of code way the heck out there. I think there's ways I can improve it still. Okay, so what I did here was I optimized this little section. What I've done is, instead of checking to see what the value of x0 is and then comparing it against the accumulator, I've literally just multiplied it. And what we've done is, when override is low, this goes high, so this is 1 always. This is 1 most of the time, except when this goes high, in which case the thing flips 0 and it multiplies it by 0, and anything that multiplies by 0 is 0. So it's a fast way to reset everything. And look, the whole thing works, and I get my power usage down to 769, so I can hold my head high a little. Okay, so the next optimization was I managed to move this gizmo actually inside this, and there's a couple of things that I've done. First of all, I skipped out on including the test for the -999 state because it will fail pretty much right away because it's less than all of these numbers. So we don't lose that much power there. That means, of course, the override input comes directly into here, and we have a P0 test here, and then we just store the state in the DAT register, because of course I was storing the state in the second digit in the DAT register, but I only need it to be tested once for where the first digit matches. Otherwise we can throw it away and forget about it. And of course, if I simulate this whole thing, does it work? Well, let's find out. 3, 4, oh yes, brilliant. So reduce my line of code down to 21. Somebody's come up with an optimization. Sorry, my lines of code are reduced down to 14. My power usage is pretty low. It's not as good as my best, which is a different version, but my production cost is right at the bottom of this. So I think I'm going to take that as my winning design. Until the next time, I'm Scott Manley. Fly safe.